effect. You know, it isn't just a short-term thing.
Oh no!
If you take antibiotics, it can damage your gut flora very long-term, if not forever. You know, you can wipe out whole beneficial species. You know, that are part of essentially your immune system.
Exactly so, and the common held belief that's amongst medical as well as the lay people is that probiotics replace your gut flora. Any gut flora that's been damaged or missed, probiotics will replace that. Well, they don't, because probiotics bacteria are alien bacteria, and your immune system will mobilise against it.
Yeah. So they give you some short-term benefits.
Yes.
But they don't last.
No, they don't assimilate.
And if you continue to take them, basically their effectiveness drops.
Yes.
Because eventually your immune system recognises them as foreign.
Yeah. Yeah. It's a similar thing with traveller's diarrhea. You know, you ingest alien bacteria, and until your immune system catches up with those alien bacteria, you've got diarrhea.
So the implications of gut flora, we know that commensal bacteria are essential for an effective immune system. We know that antibiotics impact detrimentally on gut flora, and we know that compromised gut flora is passed down the maternal line, which compounds the problem with each generation. Yeah?
That's right. We don't just acquire our gut flora plucked from the air. They're anaerobic bacteria. They don't exist in oxygen-rich environments, so they come via the mucus in the birth canal and mother's milk thereafter. But within days, we're colonised with. It's a metamorphosis. We are changed entirely. We have 10 times more cells, bacterial cells, than we do our own cells. So that's a good indication where we are with that. The next slide. Poor gut flora contributes to all inflammatory conditions and diseases.
So if you have a poor gut flora, it can make you more susceptible to autoimmune diseases, Alzheimer's, cancers, heart diseases. All of these types of chronic inflammatory diseases, autoimmune diseases, allergic diseases. Having a poor gut flora predisposes you to that, makes you more susceptible.
It does, and one thing that's not generally accepted or known is the association with mental illness. And I've got a page on the site which explains that, but it's very much a part of much, if you like, mental illness.
Yeah, I mean, one of the things that was highlighted just in the last 2 weeks, I think, on the news was that they suddenly recognised that depression is related to chronic inflammation.
Yes.
Which it's really funny, because we've actually been saying that for years, haven't we?
We have indeed. Yeah.
So what's all this got to do with bees? Yeah.
Well, bees. Yeah. Well, I knew that antibiotics had an impact on a cause of my illness, and researching antibiotics in medicine, I find that 70% of all antibiotics manufactured are given to animals, and much of it on a just-in-case basis, because they're intensively reared. They don't want the animals to get infections, so they use them as a...
Yeah, and another practice which I think isn't happening now in the UK, at least officially, is that because they found out that by giving animals antibiotics it actually stimulates growth. They've been giving antibiotics to farm animals in order to make them get fatter quicker basically.
Exactly so. And
I don't think they're doing it officially now in the UK, but I think the practice still might be going on.
Oh, the practice is very much going on. There's a huge black market in antibiotics. It was a bit of a scandal in Ireland a few years back, where the farmers were buying huge amounts of antibiotics to give to their animals, to the benefit of the animals.
So the idea is, in terms of the picture that we're showing now, an environmental pathway to immune suppression in bees. So this is a new way of thinking, which suggests a potential. It's a hypothesis. Yeah,
Yeah.
we don't have the evidence to prove this yet, but it's a logical representation of how it might be happening.
Yeah.
So we're giving antibiotics to our cattle and our farm animals. The antibiotics which then passes through the animals ends up in the silage.
Mm-hmm.
The silage then ends up in the water and in the land, and the plants basically take up the antibiotics.
Yeah, we know the plants
and we know
do
that does happen.
It does happen, yeah, it's been proved. And just to think back on the antibiotics that promote growth in animals, we don't know why that happens. We may have a clue in the obesity crisis, which has been proved to be inappropriate gut flora. That's not, we all say we're overeating, but it's not. It's inappropriate gut flora that causes obesity. It makes animals fat. The logical thing would be to say that the antibiotics alter the gut flora of the animals, allowing pathogens to invade, and those pathogens promote that they upset the metabolism of the animal, how they metabolize food. So there's your model.
So what we're suggesting is that the plants are taking up the antibiotics.
Yeah.
Then the antibiotics are then being presented to the bees in the pollen.
Yes.
Yeah.
The nectar.
In the nectar, and the bees pick it up, and the bees' immune systems are then being essentially damaged because they're taking up the antibiotics.
Yes. The bees' immune system. We're all running on the same software. Insects, animals, us, but we all rely on a synergistic relationship with gut flora to provide our immune system, and the bees are no exception. Now, if you consider that 10 milligram of antibiotic has a profound effect on the average, say, 12 stone man, woman, how much would it take to upset an insect's balance in the gut flora? Not very much. And just to throw a few figures in here, we use 350 tons of antibiotics a year on farm animals. And none of that is contained. Every last bit goes into the environment. Up to 90% of the parent compound is in the manure. It passes right through the animal into the manure. So there's your problem. It's very effectively spread on the land through muck spreading, fertilizer, and that's the complete model as you see there, the pathway.
Yeah. So what we're basically trying to do is we're trying to encourage people to basically take a look and see if this is actually happening. Yeah, because we know that it gets all the way around to the plant. What we need to do is confirm if the bees are actually picking it up and if that is actually having an effect. So that's the research that we want to take place.
Yeah, it's pretty simple stuff. It wouldn't take a lot to prove or disprove this hypothesis.
So, and the next slide basically shows that yes, we know that antibiotics are taken up by plants, and there's a reference given.
Yeah, it's a wonderful piece of work, that. Okay.
Right, so, as we said, we want to confirm the pathway. The slide we're on is redressing the balance, and not just for the bees, yeah? So we want to confirm the pathway. We would like to stop the current practice of using fluoroquinolones, ciprofloxacin in particular, as a precautionary antibiotic, because we know that's getting into the environment and causing a lot of problems.
Yeah, it's that Cipro, as it's referred to, remains in the environment longer than any other antibiotic. It binds into the soil, so it's part of the environment.